Uh, Hello, welcome to the second semester A division students for this online classes. So today we shall discuss with this resonance, the quality factor, then bandwidth, resonant frequency. After that, we shall continue with the parallel resonance circuit. So first of all, the question arises: what is resonance in electrical circuit? So, resonance in electrical circuit is nothing but at a particular frequency that we call it as resonance frequency. The impedance of the reactance of the inductance is equal to the reactance of the capacitance. Hence, the total impedance of the circuit is equal to the resistance of the circuit. The circuit behaves as a resistive circuit. So once the resonance occurs, since the impedance of the circuit is minimum, therefore the current is maximum. So with all together, we can define resonance in electrical circuit is the condition wherein the reactance of the inductance is equal to the reactance of the capacitance. Therefore, the total impedance is minimum and current is maximum. So that condition that we call it as resonance. So resonance circuits are very useful in constructing the filters. So that means there are four types of filters, that is band pass filter, high pass filter, band elimination filter and low pass filter. For the construction of these filters in many applications, these resonance circuits are very useful. So, what happens at resonance? What happens? Let us study. As you go on increase the frequency, the current in a series resonance circuit that also goes on increasing at a particular frequency, which we call it as a resonant frequency. At this frequency, the impedance of the circuit is minimum, whereas the reactance of the capacitance and reactance of the inductance, they are become equal, that is XL is equal to XC. Therefore the current reaches to maximum value. So at resonance the impedance consists only the resistive component R. The value of current will be maximum since the total impedance is minimum. The voltage and current are in phase, hence the maximum power occurs at resonance since the power factor is unity, because cos theta, that is cos pi, is 0 because current and voltages are in phase. So on plotting a graph of current against frequency, the curve is obtained as shown in the figure. The frequency for which the current is maximum is called as resonance frequency. At this frequency, the voltage across L and C is minimum. So we can define the resonant frequency is that frequency for which the current is maximum and the reactance of the inductance is equal to the reactance of the capacitance. Next we shall discuss with the sharpness of the resonance. If the resistance of the circuit is maximum, the current is minimum. That here is shown. So that R3 is equal to high, at that time the current is minimum and the curve is more blunted. If the resistance is minimum, the current is maximum. So that is R1, that is equal to low, that is maximum current is that is shown in the picture or in the graph. For R is equal to 0, the current is infinity and called as sharpness. So variation of current against the resistance is shown in this figure. Therefore, we can define the quality factor. The sharpness of the response curve is measured by the quality factor Q. the ratio of either the reactance of the inductance or the capacitance at a resonant frequency to the total resistance of the circuit is called as quality factor. Hence Q is equal to XL by R, or that is equal to XC by R. So on simplification, that we are getting 2 pi f R into L divided by R, or 1 over 2 pi f R into C into R. So from this equation, for a given value of L and C, the quality factor inversely proportional to the resistance of the circuit. Since the sharpness of the resonance is also inversely proportional to the resistance of the circuit, therefore the quality factor is directly proportional to the sharpness, that is Q is directly proportional to sharpness. So Q is also defined in terms of upper and lower half power frequencies. So let us calculate what are these lower and upper half power frequencies. So half power frequencies are the frequencies at which the power dissipation is equal to the half of its power dissipation at resonant frequency. If F1 and F2 are the lower and upper half power frequencies at resonance, then the total power dissipated at resonance, that we call it as P, that is equal to I naught, where I naught is the maximum current, I naught square into R, that is I square R, power loss, that is equal to I square R, where I naught is equal to E naught by R into R. So therefore on simplification, that we are getting E naught R whole raised to square into R. So that means you are defining the half power frequencies are the frequencies at which power dissipation is equal to half of its power dissipated at a resonant frequency. So therefore P1 is the power dissipated at lower frequency, lower half power frequency, for which the power loss is equal to 1 by 2 times the maximum power. So therefore that is equal to P1 is equal to I1 square into R. So that is equal to half of the total maximum power, that is 1 by 2 E naught whole raised to square R into R. So on simplification, that you are getting I1 is equal to 1 by root 2 into I max, where maximum current, that is the maximum current at resonance. I max is the maximum current at resonance. So similarly, the current I2 can be written in the same manner. Okay, that is P2 is the power loss at a higher frequency at which the current in the circuit is I2. So once again, if you go in the same manner, that you are getting that I2 is equal to also equal to 1 by root 2 I max, where I max is the maximum current. Hence, at lower and upper half power frequencies, the current amplitude becomes 1 by root times the maximum current at resonance. Therefore, half power frequencies are the frequency when the magnitude of the output voltage or a current decreases by the factor 1 by root 2 from its maximum value, also known as cutoff frequencies. At cutoff frequency, the currents are given by, that is I1 is equal to I2, that is equal to 1 by root 2 times I naught. So that is 1 by root 2 times I max, where I max is the maximum current at resonance. Therefore, I can write I1 is equal to E naught square root of R square plus omega L minus 1 over omega C whole raised to square, and that is equal to 1 by root 2 times I maximum, or that is equal to 1 by root 2 E naught R. On equating these two equations, so that you are getting equation number 1. So on squaring this equation number 1, we have, so on squaring and simplification, that you are getting at F1 omega 1 L minus 1 over omega 1 C, that is equal to minus R, that is equation number 2, because this omega 1 L is less than 1 over omega 1 into C. At F2, omega 2 L minus 1 over omega 2 is C, that is equal to R. So because that omega 2L is greater than 1 over omega 2C. Adding equation number 2 and 3 that and simplification, so that we are getting omega 1 into omega 2 that is equal to 1 over LC, that you have to take equation number 4. Since omega r that is equal to 1 over square root of LC, because FR is equal to 1 over 2 pi square root of LC, therefore 2 pi FR that is nothing but omega r that is equal to 1 over omega 1 over square root of L into C. So with this, that equation number 4 that becomes omega 1 into omega 2 that is equal to omega r square. Subtract equation number 2 from 3. So then this above equation, this equation number 2 can be subtracted from equation number 3, and on simplification that you are getting that equation number 5 that is omega 2 minus omega 1 that is equal to R by L. But according to Q factor, that is quality factor, that is given by Q is equal to omega R into L divided by R. So that is equal to omega R. Since this, from this equation number 5, that is R by L that is equal to omega 2 minus omega 1. Bring this L to the denominator, that becomes R by L that is equal to omega 2 minus omega 1. So therefore omega R is equal to 2 pi FR, and here in omega 2 minus omega 1 2 pi is common, so F2 minus F1. So 2 pi get cancelled, that in terms of frequencies, that is resonant frequency and half power frequencies, that quality factor Q is given by FR divided by F2 minus F1. So that means the quality factor increases, okay, that is directly proportional to the resonant frequency, and the quality factor is inversely proportional to the bandwidth, that is F2 minus F1, that we call it as a bandwidth. Okay, so therefore the quality factor Q that is equal to FR upon 2 times delta F, where 2 times delta F is called as the bandwidth. Therefore this F1 is equal to FR minus delta F, and F2 is equal to FR plus delta F. So that is shown. What is delta F? Is the, it is the frequency difference between the resonant frequency and lower half of frequency. Similarly, delta F is also equal to the frequency difference between the resonant frequency and upper half power frequencies. So here 2 delta F is called as bandwidth. In other words, quality factor can also be defined as the ratio of resonant frequency to the bandwidth. So bandwidth is the difference between the upper half power frequency, lower half power frequency. So therefore bandwidth that is equal to 2 times delta F, that is equal to F2 minus F1. Now you can define the voltage magnification. At resonance, the potential difference across the inductance and capacitance are equal and opposite, that is 180 degree out of phase, hence cancel each other. At resonance, there is potential difference across resistance, therefore the current in the circuit is maximum. The potential difference across resistance that is equal to I max into R. The voltage magnification in LCR circuit is defined as the ratio of voltage across inductance or capacitance to the voltage across the resistance at resonance. Since that voltage magnification is defined by the letter M, that is equal to voltage across inductance divided by voltage across resistance, I naught into reactance of the inductance, that is omega R into L, divided by I naught into R. I naught get cancelled. So therefore that is equal to omega R into L divided by R, which is nothing but the quality factor Q. Okay. So therefore Q is equal to M, and that is equal to omega R into L divided by R. So that is also equal to, so substitute the value of omega R. So and simplify it, that is 1 over square root of LC, and simplifying that you are getting 1 upon R square root of L into L square root of L divided by C. The same thing that you are obtaining for capacitance also. Next, we shall discuss with the parallel resonance circuit in the next video slide.